forgot the video in first period. Pythagorean theorem only works for right triangles, so you have to have a right triangle. If you do, when you square the legs and add them together, it equals the hypotenuse squared. Now, just to recall these things, I know we talked about this before, but the legs are the ones that make up the right angle. So if they make up that L shape, those are our legs. We call them A and B. Hypotenuse is C, which is across from the right angle. The hypotenuse is also the longest side. So we see that longer side there. That's our hypotenuse. It's across from the right angle. So let's do some examples. Here's our first one. Now this one, we see that right triangle there. We see the right angle. We can set up our Pythagorean theorem. Before we set it up, let's label our three sides. Which side would be A? Before, what side is B? And C? X. Now, A and B are also interchangeable. It really doesn't matter which one of those are A and B, because if you look at the formula, addition is commutative, so they can switch places. But if I set it up, A squared plus B squared equals C squared, I would say 4 squared plus 3 squared equals X squared. Now, what is 4 squared? 16. 3 squared is 9. So we start off with simplifying, and if we square those numbers, that's how we first simplify. Then we could add them together because they're on the same side. Yep, we'll talk about that later. Yep, but then we square root both sides and get x equals 5. Now, if this was a solving an equation, we would put a plus or minus in front. But do we put a plus or minus in front with this type of problem? No, we're talking about a side length. Can a side length be negative? No, so you don't need the little plus or minus. X just equals 5. So you don't have to worry about plus or minus for this unit. Okay, copy down your second picture. Now let's label our sides. What side would be A? X. And B would be 5. And again, those can be interchangeable. I heard somebody else say 5 with A. It really doesn't matter as long as that part is the part that makes that right angle. So C is 15, the longer side across from the right angle. So set up your equation. A squared plus B squared equals C squared. Or in our case, X squared plus 5 squared equals 15 squared. Yeah, Dayton? As long as C is on the other side, A and B doesn't matter the order. They can switch. Nope, it doesn't matter. What is 5 squared? And 15 squared? Good. So first off, you square all the numbers that you can. Then get the x by itself. How am I going to get x by itself? Subtract the 25. And that leaves me with x squared equals 200. Square root both sides. But if I take the square root of 200 in my calculator, I get a decimal. We don't want decimals. We want to break it down. Yeah, let's find the biggest square root that goes into it. What multiplies to be 200? Let's use 2 and 100, right? Because what do you know about 100? It's a perfect square. What's the square root of 100? 10. Oh, Lord, I clicked something crazy. Cancel. Okay, there we go. So x equals 10 square root of 2. If you find a number that's a big perfect square, use it. This one I think is easy to see because 200 is 2 and 100, square root of 110, and the 2 stays underneath. But we'll do some where we break them down all the way later. Yep, we got another triangle here. Go ahead and draw that one. Let's label our sides. A, B, C. I like to label them. You guys don't have to if you don't want to. It's just something I like to do, especially starting out doing Pythagorean theorem. So we do 4 squared plus x squared equals. Now, when you have more than one thing that you're squaring, think about putting parentheses around it and a squared on the outside, because it is kind of like we have two things here. We have a 2 and a square root of 5. Okay? So let's go ahead. It would. If you square the square root, yes, that would. Let's simplify it in just a second. What's 4 squared? 16 plus x squared equals. Now, there are two ways to do this number, and I'm going to write it up at the top since I don't have room to the side. If something is squared, you could write it twice, right? So if you wrote that twice, remember how we were just doing this on the last unit. Multiply the numbers outside, the numbers inside. What is 2 times 2? 4. What is square root 5 times square root 5? It's the square root of 25, which is the same thing as 5. And what's 4 times 5? 20. Now, another way that you could do this too, and you could do it either way, you could actually put a squared on each of those numbers. Since it's a product that's being multiplied, you could square them individually. What's 2 squared? What's square root of 5 squared? 5. The square root cancels, right? So you end up with the same thing, 4 times 5, which is still 20. Now, what's my next step to solve? What? 20 minus 16 is 4, and then so x is 2. No, the drawing is not always accurate because I just usually take a picture from above and just throw it down there. So don't trust the picture. Just, that line should really be there. We'll just white this line out to make it more accurate. Ta-da! It's fine. Okay, do the next picture. Drawings are not always accurate. Draw that next picture. Oh yeah, you can make it 4, 5, 6. Yeah, sorry about that. 4, 5. Thank you. 6. Thank you. Yeah, sometimes you might see shapes inside of shapes and additional shapes. Yes, that one is a square in the middle picture. Well, we're not going to worry about those yet. But we are going to look at this. We are going to look at this triangle here, number 4. You guys have already noticed, y'all see 2 right triangles, right? But it does look like a reflection. What is the big triangle, the overall, the outside? Well, the side here is 16. It is equilateral. How do you know it's equilateral? The angles. See how this angle is equal to this angle, which is equal to this angle. All angles equal, then all sides are equal. And then somebody already said the length of this side at the bottom is 16. So which means that all 3 sides are 16. Now we can focus on one of these right triangles. I'm just going to pick the one here to the right. Right triangles to the right. And then we can use our Pythagorean theorem to solve. So what is A? X squared plus 8 squared equals 16 squared. So using this as A, B, and C. What is 16 squared? What is 8 squared first? 64 equals 256. Bless you. Now subtract the 64. 192, which you already just mentioned that is not a perfect square because we're going to have to square root. So we need to make a, Ooh, 64 goes into this number how many times? 3. It's nice to have friends to check those for you. 64 times 3 is 192. But if you forget, keep making your factor tree. We've done so many of those. But x would equal, what's the square root of 64? 8. And then leave the 3 under. 8 square root 3. But again, if you want to continue making that factor tree, you're just going to have 3 groups of 2. So a 2 times 2 times 2 is 8. 3 stays under. Yeah, Dayton? It is a part of, because you're doubling that number, it does make it interesting. And this is actually a special kind of triangle that we're going to talk more about on Monday. All right, draw number 5 if you have not yet. And Edward, you noticed something about number 5. What did you say? It's a triangle, a right triangle, and a square. Hold on 1 second, my phone's ringing. Driving will be tomorrow instead of today. Okay, so what do you know about a square? All the sides are the same, so I could put a 3, 3, and a 3. And then I'm going to focus on my right triangle, which is here, and I'm going to use my old Pythagorean theorem. What would you put for A? 2. 2 squared plus 3 squared equals x squared. Which, yes, whoever yelled out the answer there was right, too. So what is 2 squared? 3 squared. And 4 and 9 make 13. Now, we need to, that's right, 13 is one of those prime numbers. We can't break it down, so my answer is just the square root of 13. Sorry. No. All right, let's go ahead and go through Pythagorean theorem on the next one. It's already set up with the right triangle. Here's our A and B makes up the right angle. So 4 squared plus square root 5 squared equals x squared. 4 squared is, what's square root 5 squared? It's just 5. Yep, they cancel out. And 16 and 5 make, and now we want to square root both sides. What do you know about 21? Yeah, it's just 7 and 3. So are there any pairs? Can we break it down? No, so just leave it at square root 21. You just reminded me of Luigi by saying like no that way. Like we've been playing a lot of Mario Kart at my house, so Now we're going to do 3 more problems like this because I want to make sure that you understand how we can use Pythagorean theorem with different shapes and different things that occur. So let's look at another example. No, we got more. So draw down that first picture. I guess this will be 7, 8, 9, or 7. We have 4 more examples to do after these 3. So I guess 7. 4 and 3 make 7, right? We have this slide and 2 more slides to do, if that helps. Yeah. So what we have in number 7, when you look at where x is actually the altitude, if anybody remembers that. It's how tall the triangle is from the base to the absolute height. So our base is 48. That's the area of a triangle. Yep, 1/2 base times height. But here we're just trying to figure out what x is. In general, look at the overall triangle. What kind of triangle is that? It's isosceles. It's isosceles because we have 2 sides equal. Now, this is a theorem that we talked about way back when, but in isosceles triangles, if you have a perpendicular that hits the other side, it splits that side in half. So both of these segments are equal, and they would both be what? 24. So now we can look at this right triangle here with those 3 segments and set up our Pythagorean theorem. X squared plus equals 26 squared. So use those as your 3 measurements. Now let's use our calculator to get some squareds here. 576 and 676. Those are a little bit nicer. Now what do we do? And what does that give us? 100. We subtract our 576. That gives us 100, which means that altitude in the middle is 10. Square root of 100 is 10. Not this unit. Now, in the next problem that we have, if we want to find x, x is in this triangle to the right. So if I trace it, I need to figure out what y is to help me figure out what x is, right? So I just went ahead and threw a little y in there to help us find it. So I'm going to have to use this right triangle on the left to help me figure out y, and then I can use that to help me figure out x. So sometimes you may have to do a little bit more. Hey, Jasmine, while I'm talking, can you please not talk because it's starting to really bother me? All right, so we need to do our Pythagorean theorem. Let's set it up. Y squared plus 4 squared equals 4 square root 5 squared. Yep, keep parentheses around that one because remember, we got to square everything there, just like we did in that 3rd example we did today. So y squared plus 16 equals, now think about putting little squares on both of these up here. What's 4 squared? Well, you got to square that one too. So what happens to that one? Or what's the square root of 5 squared? 5. Well, somebody said 25. That's all I heard was 25. Oh, I thought you meant it would stay square root 5. Yes, it would stay as a 5. I thought you meant it would stay as a square root of 5. I'm sorry. What's 16 times 5? 80. So we're going to put 80 here. Now, if you want to do this in your calculator, you guys actually can. So if you're afraid you're going to forget, you have to use parentheses, or you could just type in the number, hit enter, and then squared and enter. And it gives you that answer. So quick, easy check if you have a calculator. Now, what are we going to do? Subtract 16. What's 80 minus 16? What is it? 64. So y is 8. Which that's nice. If that part equals 8, now we can look at this triangle to the right and set up our Pythagorean theorem. How would we set that up? 8 squared plus 16 squared equals x squared. 8 squared is 16 squared. Y'all were saying it so fast. Whoa, that looks like a bad 3. I don't know what that was. 320. Look at you, you're too fast. Okay, we're pause. Pause. Calculators work fast. No, I don't think we got that yet. Now let's square root both sides, but it won't square root, so we need to make our factor tree. 64 and, I know 64 has been popular today, 64 and 5. So x equals, what's the square root of 64? 8 square root 5. Didn't circle that one. We have some fast calculators in class today. They are on top of it. Speedy. Joe is speeding through them. But you guys know Pythagorean theorem pretty well, right? So it's just getting that math done, getting those numbers typed in. Now, number 9 is pretty similar to or 7. 7 that's up here on the board. Because if we want to look at, let's say we want to use just this bottom right triangle here with Pythagorean theorem. I know this side's x. What's this side on the left? 1. Because this gets split into 2 equal pieces, right? 1 and 1 makes 2. So if I set up Pythagorean theorem, x squared plus 1 squared equals 3 squared. Oh, sorry. Y'all have to pause. I forget. I forget y'all are drawing the triangles. I will slow down. I'm so sorry. I just go, they're already there for me. So I'm like, let's go. I get too excited about math. Problems. Well, I always, I might need a therapist. I'm come. We're going Friday. Hello, therapist. I get excited about math. It's a problem. All right, let's square our numbers. What's 1 squared? All right, what's 3 squared? And then, and we get 8 is 4 times 2, right? So if we break that down, it would be 2 square root 2. Because square root of 4 is 2. This 2 stays under. So what we're going to do next is we are going to have a word problem. So just try to copy down, you can shorten some of the words a little bit, but read through it, copy down the important information, or maybe draw a picture with it, but I'll give you time to write that down. But make sure you use Pythagorean theorem correctly in the problems that you do for homework. I believe you have 9 of these to do where I give you a triangle and you find one of the missing sides. And then you have 4 word problems for homework, but we just have 1 for our notes. So draw that. Or write the words. Sorry, not draw. Write the words. Draw, right? No, you can. Yeah, you can. Yep. They're saying in here, we know it's a right triangle. Can we just draw a right triangle? Sure. It's up to you. They're your notes. Whatever's going to help you, that's what you do. It does. Let's get everybody to. I can't. I will do it once I know everybody's finished writing, and then we'll do the problem together. But if you want to take a guess, you can. But read the words. There's not actually too many lessons in this unit. Like what we're going to do tomorrow, we're going to focus on just like looking at it as triangles. Then what we do on Thursday, we're going to do word problems that deal with tomorrow. Then Monday, we're going to do special right triangles. And then that's it. So it's really only 3 units or 3 days, I guess, in this unit. That's new stuff. Oh, but they're fun. We get to sing a song. I will sing it. Okay. So this so our problem says a painter leans a 15-foot ladder against a house. The base of the ladder is 5 foot from the house. To the nearest foot, how high on the house does the ladder reach? So if we were to draw a picture, here's my house. Here's my ladder. Here's the ground, right? Draw a better ladder. There's my ladder. There's my ladder. Okay. So, so where do I put the 15? It's the leaning one. It's the hypotenuse. Where do I put the 5? The bottom, because it said keyword there is base. Then the question, how high on the house? Well, this is my house. How high on the house does the ladder reach? So see how I could make that into a right triangle very easily. Now let's set up our Pythagorean theorem. X squared plus 5 squared equals 15 squared. So I like to draw a pretty picture. Seeing that a pretty picture? It's all right though. It's a cartoon house. It can look like it's about to fall. What's 5 squared? 5 squared is 25. What's 15 squared? 225. Then okay, now on this one, since it's a word problem, we're not going to answer as like 10 square root 2 or whatever. We are going to just round to the nearest foot. So I would just type in your calculator square root of 200, and that's how you answer most word problems. You just round them. 14.14. Jasmine, all I hear is you talking about other things besides this math problem. Okay, then what kind of units are we going to put on it? Feet. And it did say nearest foot, so we could actually just say 14 feet. Now, make sure that you put units when you have word problems and just read to what to round to. I believe on the homework I said round to the nearest tenth, which is how many decimals? One, just one. All right, write down this. This is what you were talking about there, Dayton. Some Pythagorean triples. Write this down. This is our last slide. Yes. Would it? Try it out. I'm sorry. If you look at the hypotenuses, they're in order. So just a little history lesson for you guys. Back in 3000 BC, there was a group called the Babylonians who lived in like, is it modern day Iraq area? Between the Tigris and Euphrates rivers and that around Mesopotamia. Anyway, back in 3000 BC, they actually used Pythagorean theorem for their irrigation of their plants and water system that they use. So Pythagorean theorem has been around for over 5,000 years. However, it's named after Pythagoras. Back in ancient Roman Greek times, he kind of coined the theorem that we use today, and that's why we call it Pythagorean theorem, based off Pythagoras. So Pythagorean triples are non-zero whole numbers that satisfy the Pythagorean theorem, like 3, 4, 5, 5, 12, 13, 8, 15, 17. When we used to have the traditional schedule of classes where you guys took like Algebra 1, Geometry, Algebra 2, your parents probably went through that sequence. We spent a whole semester talking about all geometry, and these Pythagorean triples are ones that people like automatically notice. They're like, oh yeah, that's Pythagorean triple. That's Pythagorean triple. And you could just write it down instead of doing the Pythagorean theorem. But also, Andrew was mentioning any multiple of these will work. So if you look at 3, 4, 5, and you multiply all those numbers by 2, 6, 8, 10, that's a Pythagorean triple. You could also triple the numbers, like 9, 12, 15. So anything that you multiply all three numbers by the same amount will give you a Pythagorean triple as well. But these are the basic ones with more of the prime numbers, because when you look 5, 3, 13, 17, 7, those are prime numbers. All right, the next thing we're going to talk about is the converse of the Pythagorean theorem. The only thing that changes is the symbol in the middle. If the symbol is equal, it's a right triangle, greater, acute, less than, obtuse. So what a converse does, just while you're writing this down, it just switches the if then statement. And again, if we had a traditional geometry course, we would do that for all kinds of statements. But we're saying if the equation works, then it's a right triangle. But if the equation doesn't work, it's a different kind. So I'm going to try to draw some really bad pictures of these. They turned out better in first period. So on your homework, I think you have 9 or 10 problems where I give you a triangle and you have to find one of the side lengths. Then you have 6 or 7 problems that are like word problems. So you might want to draw a picture or think about them. I always say draw a picture. It really does help. I'm a very visual person, so I have to draw pictures. And then you have 4 problems where you decide, is it a right triangle, an acute triangle, or an obtuse triangle? So like the examples we're getting ready to do. If anybody wants to be a surveyor or landscaper or architect, this unit is your unit. That's right. It's what you would do for the rest of your life or change your career. Yeah, Bryce, I guess you could be like, nope, not for me. Go ahead. Exactly. Yes, and that's what we're trying to pick out. So we are given 3 segments, and we're going to say, if I had these 3 segments measured out in like inches, centimeters, or whatever, what kind of triangle could I make? Because you cannot make a right triangle out of any 3 segment lengths. So like, let's say we're given 3 straws that are cut into 6 inches, 11 inches, and 14 inches. What kind of triangle would it make? So what you need to do first, and make yourself a note, you need to find C first. And C is the largest because they're not always written in order. So you want to pick out which one of those numbers is going to be C. Which one of those numbers is the largest? 14. Definitely. Now, I always just leave some space. So I'm going to do a squared plus b squared and see how does it relate to c squared. There's going to be like a symbol in there between. So a and b are interchangeable. So I'm just going to put 6 squared plus 11 squared. And then to the side, I'm going to put 14 squared. Now, what is 6 squared? 36. What is 11 squared? If I added those together, 157. Now, go over to here. What is 14 squared? 196. Which one's bigger? 196 is definitely bigger. So when you're writing your inequality, you would say 157 is less than 196. If you put a less than symbol, then the triangle is obtuse. Here's how I remember it. If we closed in the letter C, it makes the letter O, right? O, obtuse. If C is bigger, then it is obtuse. Now, on a test or quiz, I want to see this work. So make sure you show the work. If you just write the word, you won't get full credit. You'll get some credit. But quiz, test, homework, I'd like to see this work. Yeah, after 90 degrees is obtuse. Yeah. All right, pick out C first and number 2. What's C? 9. So 7 squared plus 8 squared, how does that relate to 9 squared? Well, 7 squared is 8 squared. You go ahead and move over here. 9 squared is 81. What's 49 and 64? 113. How is that related to 81? It's greater, so acute. So if the left side is bigger, it's acute. And how I remember is A is on the left side, so acute. If the side with A is bigger, it's acute. Now, when you see a problem like this, 1, 3, and square root 5, you have to figure out which side is the largest, right? So I would just use your calculator. Square root of 5 is about what? Let's just type it in. Huh? 2.24. It's about 2.24. So 3 is the largest. Now, when you set up the equation, you want to use square root of 5, but you might want to use your calculator just to say, hey, what is this number about? So that way you know what to set up. So it's going to be 1 squared plus square root 5 squared, and then 3 squareds over here. So it may not be in order. 1 squared is, what's square root 5 squared? 3 squared. So 1 and 5 make, how is that related to 9? Less than, so we would say obtuse. And don't forget, if it is equal, it's a right triangle. I didn't do an equal example, but if it is equal, it's a right triangle. All right, I'm going to pass out the homework sheet to you guys at home. If you have any questions, let me know, but that's it for today. See y'all tomorrow.